Before question number 28, part B, this is question number 28, part B. So this is the integral that we have to evaluate, and x raised power 4. Here the degree of x raised power 4 is equal to 4. And the degree of this, I can write this as this is x cubed minus x squared plus x minus 1. And its degree is equal to 3. Now the degree 4 is greater than degree 3, so that means we have to divide. This is an improper, this is improper function because the degree of the function in the numerator is greater than the degree of the function in denominator. So what we are going to do in this case, we are going to divide x raised power 4 with the denominator, that is x cubed minus x squared plus x minus 1. And let's multiply it with x, which gives me x raised power 4 minus x cubed plus x squared minus x. Subtract this, change the sign, and this gets cancelled. So this is now x cubed minus x squared plus x. So multiplying it with 1 again, that gives me x cubed minus x squared plus x minus 1. But here there's change the sign, so this is plus 1, negative 1 plus 1. Okay, this becomes, this gets cancelled, this gets cancelled, this gets cancelled, this is 1. Okay, that means I can write this integral I as x plus 1, so this becomes x plus 1 plus 4. So 1 upon x cubed minus, this is x cubed minus x squared plus x plus 1, which is this which was originally this function. So I can write it as x minus 1 into x squared plus 1 into dx. So this is now easy to integrate. So it becomes I is x, it's x squared, and integration of 1 is x plus, let me consider this function as I1. So let this be equation 1. And so let me find out now. So this is I1, and I'm going to integrate this using the partial fraction method. So this is I1, and okay, let me use the partial fraction method here. Okay, now this, according to the partial fraction method, I can write this in the form. So this becomes 1 upon, this is x minus 1 into x squared plus 1 into, this can be written as, I can written as a upon x minus 1 plus bx plus c upon x squared plus 1. Okay, let's take LCM. So if I take LCM, x minus 1 into x squared plus 1, let's take LCM on this side. So this is x plus 1 into x squared plus 1. So a into x squared plus 1 plus bx plus c into x minus 1. So this gets cancelled. And finally, we have a is equal to a into x squared plus 1 plus bx plus c into x minus 1. Okay, put x is equal to 1. So 1, if I put x is equal to 1, this becomes 2a. And this term reduces to 0 because 1 minus 1 is 0. So we have got a. So a is half. Now let me put x is equal to 0. So if I put x is equal to 0, 1 is equal to a. 0 plus 1 is 1 plus b. b into 0 is 0. So we are left with c, and 0 minus 1 is negative 1. So this gives me 1 is equal to a minus c. And now c is equal to 1 minus negative a, which gives me 1 minus half is equal to half. Okay, actually, so we have got the value of a and c. and this should be so C should be equal to this should be equal to A minus 1. And A minus 1 means half minus 1, which gives me A as negative half. Okay, now let me put x is equal to negative 1, which gives me 1 is equal to A. Negative 1 square is 1, so this is 2A plus this is negative B plus C and negative 2. So 1 is equal to 2A plus 2B minus 2C. Now 1 is equal to 2 into A is half, 2B minus 2 into C is negative half, which gives me 1 is equal to 1. Sorry, 1 plus 2B plus 1. So 2B is equal to negative 1 and B is again, so B is negative half. So that means I can write this now, this integration, this can be written as integration of this. So this is now I1 is integration of A, which was half. So x minus 1 plus B. B and C are negative half, so this becomes negative half into x minus negative half upon x squared plus 1 into dx. Okay, this further, right? So this becomes half into its integration is log of x minus 1 plus. Let me separate these. So negative half is out, and this is x upon x squared plus 1, and once again minus half into 1 upon x squared plus 1 into dx. Okay. So half into log of x minus 1. This is negative half. This becomes, if I have to integrate this, so let me integrate it here using the substitution method. So let me substitute x squared plus 1 with t, which gives me differentiating with respect to t gives 2x into dx is equal to dt, and x into dx becomes dt by 2. So this is x, so this becomes half dt by t, which is half log t. So this is half log t, and t is x squared plus 1. So this is now half of log. It should be log here. So this is half log of x squared plus 1. So this becomes half log of x squared plus 1 minus half. And this is of the form x squared plus a squared, and integration of 1 upon x squared plus a squared is equal to tan inverse x by a. So I can write here this is tan inverse x a is 1. So finally I1. So I1 is now half log of x minus 1. This is minus 1 by 4 log of x squared plus 1 minus half tan inverse x. Okay, let me fill in this value here. So we have got the value. This is half log of x minus 1 minus half tan inverse x minus 1 by 4 log of x squared plus 1. So our integration, this finally becomes, let me replace the value of I1 here. So this is x squared plus x plus, let me put in the value of I1, which was half log of x minus 1. So half log of x minus 1 minus 1 by 4 log of x squared plus 1 minus half tan inverse x minus half tan inverse x plus c. So this is our integration. Question number 28 is part B.